All right, so we are about to add multiple vectors together and then use the final two vectors in a Pythagorean theorem problem, okay? It doesn't always work out this way, but when you have two different planes represented in your problem, for example, we see south and we see north, so we've got the north-south plane, but we also see east and west, so we have the east-west plane. So we know we're going to have to use Pythagorean theorem in order to add these together because we're going to end up with one vector along the north-south plane, one vector along the east-west plane. Now, let me stop using all the language and we can actually see what it looks like. So first we're going to add all of the vectors that are the same together. Okay, so we've got 4 feet south and we've got 3 feet south. So you can go through the whole steps as we presented earlier in the video, but I know this is going to give me 7 feet south. Okay, I'm going to go ahead and cross these out because we added them already. Now I have 8 feet north. I'm going to write 8 feet north on this side because this is in the north-south plane. Okay, so now I'm going to cross that out. Now we have 2 feet east and 4 feet east. So let me write that over here. I'm going to write the east-west plane. So 2 plus 4 feet is going to be 6 feet, and that is east. All right. And now we have 10 feet west as the last one. Again, I write 10 feet west over here because everything along the east-west plane I wrote in this section. Everything along the north-south plane I wrote over here. All right. Now I know I can go ahead and draw these vectors if it's going to help. So I have 7 feet south. So instead of writing south, I'm going to draw this down. And then I have 8 feet going north. Now here I have 6 feet going east. And I have 10 feet going west. So as you can see from the drawn vectors, these are both in opposite directions. So I'm actually not going to use addition. I'm going to use subtraction. So again, when subtracting, I want to start with the larger vector. So I'm going to do 8 feet minus 7 feet. That's going to give me 1 foot. And then I am going to take the direction of the larger vector, which is the 8. So it's 1 foot north is my final answer for the north-south plane. Now for the east-west plane, I have 6 feet going east, 10 feet going west. So start with the larger vector. 10 feet minus 6 feet is going to equal 4 feet. And use the direction of the larger vector. So that's 4 feet west. Okay. So now I have reduced my problem to just 2 vectors. And let me erase all the other work we just did so we can see this a bit more clearly. So I have 2 vectors. One vector is 1 foot north. The other vector is 4 feet west. Okay. So I cannot combine these vectors because one is on the north-south. I cannot add or subtract these vectors because one is in the north-south plane, one is in the east-west plane. So what I'm going to have to do is use Pythagorean's theorem. Now, I recommend you watch a video on Pythagorean's theorem just to learn more about the equation itself. But this is how you add vectors using Pythagorean's theorem. So we're going to have a couple extra steps that you won't find in most videos. So the first thing we want to do is we want to draw our vectors, okay? But when we draw them, we want them all to start from the same corner. So I'm just going to make a circle on my board. Every vector that I draw, both of these need to start from that same corner. So I have 1 foot going north. All right, I'm going to go ahead and erase that and just write 1 foot. All right, and I have 4 feet going west. So I need to start in this corner and draw 4 feet west. All right. Cool. So that's the first step. Second step is to create a rectangle. So I'm going to put some dashed lines and complete a rectangle here. Okay. So on a rectangle, opposite sides are equal. So I'm just going to go ahead and fill in the other sides of this rectangle. Now, the reason we did this is because Pythagorean's theorem uses something called a hypotenuse. right? And normally you're using Pythagorean's theorem to find out the hypotenuse or something related to that. If we have a rectangle and we draw a vector directly across, then this vector actually splits our rectangle into two triangles, okay? And those two triangles we can use Pythagorean's theorem on, okay? So the reason I drew this vector starting here is because, remember, I say all of my vectors need to start in the same corner. So this vector also has to start in the corner with the circle. All right, let me make this line a little straighter. Okay, so this vector is the resulting direction that this object has gone in. So it went 1 foot north, 4 feet west. The resulting direction is this diagonal here. So this is important because our final answer needs to have a direction and a magnitude. So now we have the direction of our final answer, but we have to use Pythagorean's theorem to find the magnitude. So I split this rectangle up into two triangles. If you can see that, that's one triangle, or you could use the triangle above it. Now I'm going to use this triangle down here just out of personal preference. Okay, now I'm going to make this a little bit bigger so we can see it better. So we got 4 feet, and then our resulting vector went this way, and then we had the dashed line with 1 foot. And our square, because this is a right triangle. Okay, so for Pythagorean's theorem, the equation is a squared plus b squared equals c squared, where c is the hypotenuse. A and b can be any side you want. Normally, I say the smaller number I label a, the larger number I label b. Okay, so 1 foot is a, 4 feet is b, and we're looking for the magnitude of our resulting vector. So we already know the direction that the object is going to go, but we need to know the magnitude. So now I just go ahead and plug in my variables. So I have 1 foot squared plus 4 feet squared equals c squared. Now let me go ahead and square these. Now when I square a measurement, I'm going to square the number and the units. So everything in the parentheses gets squared. So 1, and the reason is because so I'm going to end up with 1 times 1, which is 1, and then foot times foot, which is feet squared. Same thing here, 4 times 4 is 16. Feet times feet is feet squared. All right. Now let me show you that real quick. So for the 4 feet, if I did 4 feet times 4 feet, I get the 4 times the 4, which is 16. And then the feet times feet, which is feet squared. So that's why I have to square the units as well. So now I'm going to add these together. That's going to give me 17 feet squared equals c squared. Now, a lot of times people will stop here and say, okay, I have my answer. But remember, we're not looking for c squared. We are looking for c by itself. Okay? So in order to get c by itself, we have to take the square root of this. Okay, so I'm going to go ahead and move over here. So we're going to do 17 feet squared equals c squared, and we're going to take the square root of both sides. Okay, now the square root of c squared is just c. The square root of feet squared is just feet. Okay, and if 4 times 4 is 17, then maybe our answer is like 4.2 or something. Let me actually throw it into my calculator real quick. 4.123. Okay, so I'm going to round it to the hundredths place. So 4.12 feet is the value of c. Okay, now remember, this is only our magnitude. Our final answer needs to be a vector quantity. So I need a magnitude and a direction. So my final answer will actually be 4.12 feet. And this direction is northwest because it's between north and west. All right, so 4.12 feet northwest. All right, so that's my final answer. So that is how you use Pythagorean theorem. All right. Sometimes you'll just be given a problem where you're given two vectors that you have to combine using Pythagorean theorem. Here I gave you a situation where you had to add multiple vectors together, and then that gave you two final vectors which you had to combine using Pythagorean theorem because they were in different planes. One was in the north-south plane, one was in the east-west plane. All right, so I hope that this has been helpful, and have a great one.